Hello everyone, welcome back to our channel. So this is our third video related to the friction. In the first video we have discussed the friction on the horizontal surface. In second video we have discussed the friction for the inclined plane, and this is the third video we are discussing about the wedge friction. So these three parts are very important related to the friction. If you have not watched our first two videos, then I request you to go and watch the videos, because without understanding of that you will not able to draw the FBD for the wedge friction. For the wedge related friction, the FBD is very important. If you are able to draw it correctly, you will get the correct answer. And this is very important question from exam point of view. 8 marks question will be asked for the wedge friction, and if you solve it correctly, you will definitely pass this exam. So watch this video very carefully, and I will provide you some tips and tricks to solve this question, and I will make sure that you will not make any mistake in the exam. So this is a totally different view to solve the wedge friction. So we'll start with the reading the question. To raise a heavy stone block of weighing 2000 Newton, the arrangement shown is used. What is the horizontal force P is to be applied to the wedge in order to raise the block? Mu is equal to 0.25. Neglect the weight of the wedges. Now mu is coefficient of friction. It is common for all the surfaces. Neglect the weight of the wedges. Wedge A and wedge B is shown. So you can neglect the weight of wedge A and B. And a stone of 2000 Newton is kept on the block B. So we'll start with understanding the question. So first mark this word. What force P is necessary to be applied to the wedge in order to raise the block? So here the function of P is to raise these blocks, right? To raise the weight. So the function of P is to raise the weight 2000 Newton in the upward direction. So as per that we'll have the motion. So when the P force is applied on this block A will move towards left side. That will push this block B in the upward direction, and eventually that will push this weight 2000 Newton in the upward direction. So we'll analyze one more time. The P force is applied on this block that will push this block A towards left side, and that will raise this block B in the upward direction. So that will raise this weight in the upward direction. That is how the motion takes place in this question. So we can draw the friction force and the normal direction as per the direction of the motion. Now we'll assume that in some question the different statement will be given. The statement like find the force P to maintain the equilibrium, or they may ask that find the minimum value of P. So in those cases we have to consider the failure case, means applied force P is not sufficient so that the system will collapse. Find the force P to maintain the equilibrium means you have to find the minimum force P so that the system will remain in its position. When the applied force P is not sufficient, in that cases this weight will push these blocks in the downward direction. So this is the appropriate direction of motion. So block A will move towards right side and block B will move towards downside. So this happens when the condition is given for the equilibrium or minimum value of P. So in those cases the direction of friction will be different. For block A the friction is towards left side. For block B direction of friction is towards upside. So as per the given statement you have to consider the motion, and as per that you have to decide the direction of the friction. Otherwise you will make a mistake. That's why read the given question very carefully, analyze what is asked in that question, and as per that you have to draw the FBD. In this question they asked you to raise the weight. That's why the friction directions are decided as per that condition. If they ask you to find out the minimum value of P for the equilibrium, you have to consider this case number 2. But for this question we'll consider case number 1 because it is given in the statement. We'll identify the areas of friction. So friction always exists between two surfaces. So the surfaces which are in contact will have the friction. For example, for block A, this bottom surface is in contact with the floor. So friction exists between this surface. Friction also exists between block A and block B. So this is the area of friction. And friction also exists between block B and the wall. So this is also the area of friction. So in this way we have got three areas of friction or three surfaces of friction friction surface 1, friction surface 2, friction surface 3. On this surface there is no friction because only weight is kept, no motion happening. On this surface no surface contact. Also on the remaining surfaces the friction does not exist because it is not in contact with any surface, or either it is not in motion. So because of that we have got only 3 surfaces of friction. So we have to draw the FBD for the 3 surfaces. So while drawing the FBD, first start with drawing the blocks. Draw it at proper scale so that all the forces can be shown on that diagram and there should not be any confusion. So your figure should be neat and clean, so that will help to write the equation without any mistake. So this is my tip number 1. Then always start with showing the weight. Now there is no weight of block A and block B, so it is 0, but whenever the weight is given you should draw the weight on the figure. Now the formula for the weight force is m into g, mass into gravitational force. So value of g is 9.81 meter per second. How will you show the weight? Always show the weight at the center and it is pointing in the downward direction, and this is a vertical force. Please remember, the weight force is a vertical force. Weight force should be shown from the center in the vertically downward direction. So remember this point. The second point is will show the normal reaction. That's why it is called as a normal reaction. And the angle of reaction with the horizontal will be 90 minus angle of the surface. The block is in contact with the surfaces. So there exists a reaction. As per the Newton's third law, every action has equal and opposite reaction. So reaction exists on that surfaces. So it is there on the friction surface 1, friction surface 2 and friction surface 3. Now how to draw a reaction? Reaction force is always perpendicular to the surface. Remember, the reaction force is perpendicular to the surface. I will repeat, angle of the normal reaction will be 90 minus angle of the surface. Then we'll show the friction force. Now friction force is always opposite to the motion. If this block 8 moves towards left side, the friction force exists towards right side, and angle of friction will be angle of the surface. So the angle of friction here, angle of the surface. Friction force is tangential to this surface, that's why you can show it along this surface. Then show remaining forces in the figure and at the end apply conditions of equilibrium. Now we'll consider all the forces will form a concurrent force system. So here we can apply only two conditions of equilibrium, that is summation of fx0 and summation of fy0. Here we can find maximum two unknowns by using two equations of equilibrium. Now we'll start with the drawing the FBD for the figures. Now block A, it is moving towards left side, so its motion shown here. So first we'll show the normal reaction. As this reaction is perpendicular to the surface, it is shown here. This is known as N1. Then block A is moving towards left, so friction force is shown towards left side. The value of friction force will be mu into normal reaction. So it is mu into N1, so it is equal to 0.25 into N1. After showing the friction force and the normal reaction, we can shift to this surface. Now for this surface, you should consider the x-axis and the y-axis. So show the normal passing through the origin and perpendicular to this surface. The value is n2. Now the angle of n2 will be 90 minus angle of this surface. Now the angle of this surface is given 15 degree. So here we get this angle is equal to 90 minus 15 degrees, so it is equal to 75 degree. So in this way we can draw the normal reaction. Now show the friction force. Friction force is tangential to this surface, and as the motion is towards left, the friction force should be towards right direction. So the value of friction force is equal to mu into N2. Now we can transfer this force from this point to this coordinate system, because it will simplify the figure and avoid the confusion. That's why you can draw the parallel line passing through this point to show the friction force. Direction will remain same, opposite to the motion. 0.25 into N2, and the angle of friction force is 15 degree, that is the angle of this surface. So as per the rules, we have shown the friction force normal. Now we'll show the forces present in on this block. The only force present is P force, it is acting towards left direction. So this is the FBD for the block A. Now going to the block B, this is the motion of the block B in the upward direction. So show the coordinate system. Now the very interesting thing about this block is that the surface of block B and this surface of block A are in contact and they are on the same surface. So here we can show the normal reaction and the friction force for the block B in the opposite direction to this one. Then draw the normal exactly opposite to this normal and perpendicular to this surface. So we'll show it with the notation N2 because both will have the same magnitude but opposite direction. Same like this, it has an angle equal to 90 minus 15 degree, 75 degree. Then show the friction force. Friction force is opposite to the motion, so opposite to this force. We'll show it here. So the value is same, mu into N2. Angle is same, 15 degree, and the value is mu into N2. So it is 0.25 into N2. So as these surfaces are common, we have to show the friction force and the normal exactly opposite to each other. So we'll go for the next surface. This surface is in contact with the wall. Show the reaction perpendicular to this wall. This is your N3. Then the block will move in the upward direction like this. So the friction force opposite to the direction, so it is downward. The value of friction force is equal to mu into N3, that is 0.25 into N3. So in this way we have shown all the normal reactions and the friction forces for this block. Now the remaining force is the given 2000 Newton weight which act on this surface. Right, so this complete the FBD for block A and the block B. Remember, these are very important point. First, show the normal reaction. Normal reaction is perpendicular to the surface, as the name suggests. Normal means perpendicular. Draw the reaction perpendicular to the surface. The angle of reaction will be 90 minus angle of the surface. Then friction force is tangential to the surface, so it will have the same angle like the surface. Show the friction force, and the value of friction force is equal to mu into normal reaction. Now in this way, if you show the normal reaction and the friction, that will minimize your confusion. So for simplicity, you can start with any block. Just you have to consider the FBD of that particular block and apply the conditions of equilibrium. Now the hero of this question is the P force. So the entry of the hero always at the climax. That's why we'll consider block B. Or in second logic, you can consider for block B, N3 and N2, only two are unknown. But for block A, N2, N1 and P, three are unknown. So as per our discussion, conditions of equilibrium are only two. So we can solve maximum two equations at a time. That's why we can start with block B. So we'll start with the block B. We'll only consider the FBD of block B. So consider wedge B and applying conditions of equilibrium for wedge B. So first condition of equilibrium is summation of Fx is equal to 0. So identify all horizontal forces. So what is the first horizontal force here? N3, N2, 0.25 N2. Only three forces will come in the equation. So start with the N3. It is towards right side, so N3. Then N2. It lies in a second quadrant, so its value is minus. So it is minus N2 cos 75. The next one is 0.25 N2. It lies in the third quadrant, so its value is negative. So minus 0.25 N2. That is into cos 15. Angle is 15, so cos 15 it is equal to 0. So this complete your equation. Now rearranging this equation, that is N3 term to one side plus take common N2 from the remaining equation. So N2 into minus cos 75 minus 0.25 cos 15 is equal to 0. So this is your equation number 1. Getting? First write the equation for the summation of Fx and then rearrange the terms. After that write the equation for summation of Fy is equal to 0. Now the value of summation of Fy is calculated by adding all vertical components. So here vertical components are 0.25 N3, N2, 0.25 N2 and 2000 Newton. So write the summation, start with 0.25 N3. So it is a downward force, so it is minus 0.25 N3. The next component is N2. It is in a second quadrant, so Y component is positive. So N2 sin 75. 0.25 N2 is in third quadrant, so y component is negative, so minus 0.25 N2 sine 15, and at the end 2000 Newton, it acts vertically downward, so it is minus. Rearranging the terms, so first term is minus 0.25 N3, then N2 common, so remaining terms are sine 75 minus 0.25 into sine 15. This 2000 Newton goes to right side, so here it is equal to 2000 Newton. So this is your equation number 2. Now we have got equation 1 and equation 2. By solving these two equations, we'll get the value of N2 and N3. So by using calculators, you can solve it. If you don't know how to use the calculator, you can write it in the comment box. I will make a video on that. Here we get the value of N3 is equal to 1289.19 Newton and the value of N2 is equal to 2576.83 Newton. Now we'll consider wedge A. We'll not consider any force which is present on the wedge B. So only consider the FBD of wedge A. The value of N2 is already calculated, so we can use that value here. Now by applying conditions of equilibrium. So start with summation of Fy is equal to 0. Why? Because P force is unknown and P is the hero of this movie. So it comes under summation of Fx equation. That's why we'll start with summation of Fy first. Now vertical forces are 0.25 N2, N2, N1. Only 3 forces are vertical. So here we can write N2. It is in a fourth quadrant, so y component is minus N2 sine 75. The next one is 0.25 N2, it lie in the first quadrant, y component is positive, so plus 0.25 N2 sine 15. The next component is N1, it is vertically upward, so value is positive, so it is equal to 0. The value of N2 is 2576.83 Newton. So we can put this value of N2 in the above equation. So we'll get the value of N1 is equal to 2322.3 Newton. Just you have to write summation of Fy, separate out N1 and put the value of N2, you will get the value of N1. Then we'll write summation of Fx equation. Horizontal components are N2, 0.25 N2, 0.25 N1 and P4. So 4 component will come here. So start with N2. N2 is in fourth quadrant. So X component positive. So N2 cos 75. 0.25 N2. It is in a first quadrant. So X component positive. 0.25 N2 cos 15. The next one is 0.25 N1 right side. So it is positive. And the P force is towards left side, so it is minus, so it is minus P is equal to 0. So take this P to the right side, so it becomes the remaining equation as it is, but it is equal to P force. Now the value of N2 and N1 is already calculated, so we can substitute the value of N2 and N1 in the above equation to get the value of P force. So the value of P force is equal to 1869.76 Newton. So in this way we can calculate the value of the required force to raise the weight of 2000 Newton, and the value is 1869.76 Newton. At the end, we'll summarize the FBD for the given figure. The frictional FBDs differ from the regular FBD in respect to the two factors. The first factor is the normal component and the second factor is the friction force. The normal reaction is perpendicular to the surface in contact. So draw the normal reaction perpendicular to the surface, and the angle of normal reaction will be 90 minus angle of the plane. So here the angle of plane is 15, that's why 90 minus 15 is equal to 75 degree is taken. The friction force depends on the direction of motion. So it is always opposite to the direction of the motion. So here you can see the friction force is opposite to the direction of the motion. Friction force is opposite. The value of friction force is equal to coefficient of friction into normal reaction. So it is mu into N2. Then the angle of the friction force is equal to the angle of the plane. As the friction force is tangential to the plane, its angle will be same like a plane. So here the angle is 15 degree. For the common surfaces, when the two wedges have the common surface, you have to draw the normal reaction and the friction force opposite and equal to each other. So as per that, we have drawn the N2, 0.25 N2, 0.25 N2 having the same magnitude but opposite direction. Okay, if you don't able to decide the direction of the friction force, you can consider the second wedge and decide the direction, and as per that you have to draw the opposite direction on the other side. Okay, then show the weight forces if available and show the any external forces applied on that particular block. So if you're able to draw it, as you will solve this question very easily, and this is very interesting video. It will solve your all doubts related to the friction. You can watch this video multiple times to get a better understanding, and if you have any doubt you can write it in the comment box. Happy to solve all your doubts. If you find this video helpful, you can like this video, share this video with your friends. Thank you very much.